So now I'm going to talk about once you have the historical data and you've converted it to not 2012 or 2011 dollars, i.e. you've taken out inflation, we're going to look at how you might forecast into the future. So I'm going to show sort of two steps in this process. The first is I'm going to just do a trend line, which means I'm going to predict earnings based on the year. Now this is JMP or JUMP, which is a SAS program, but it's very similar to Minitab or any other statistical analysis program that you're going to use. So the first thing you're going to do is I'm going to hit an analysis. In this case, it'll say fit Y to X. So I'm going to predict earnings, or the Y value, based on the year. So that's just a trend line, meaning that the only thing that's influencing earnings is the year. So you can see I have this data here, and in this program the way you look at it is you look at fit the line data. So they've put a line through this, and I'm gonna look at this and help you interpret what this data means. So what I've done here is all of these years, and these are the earnings value, and I just have a trend line going through it. And this is the equation for the trend line. The intercept is at minus that huge number. But for each year, it goes up $275. So we look at the R-square, or how good that fit is, and it's about 0.55, which is not that great of an R-squared. We want an R-square in the 80s or so to get a good fit, but we're going to continue to look at this. The other thing we're going to look at is the fit of the model, and this shows sort of an ANOVA value, and it shows that the model is a pretty good fit at 0.008. And you can see that it's small enough. This is great. It shows this data. It shows that it's small enough that the probability of getting an even more extreme statistical given, anyway, I'm not going to read that. But then you also look at this and you want to see, well, which is more significant. Is the intercept significant? And we don't really care that much if the intercept is significant because it's a funny number anyway. We do care if the slope, sorry about that, if the slope is significant. In this case, the t-value is measuring, is the slope significantly different than 0? And in this case, it's not. It is. So the null is that it is equal to 0. So in this case, we can reject the null in that this value is not 0. So this is a okay fit model of 0.55 R-square. So that's the first thing I want you to do, is run each of the divisions earnings models so you can see if they can forecast into the future, and you can get a fit of, if it's better than 0.55, that'd be good, like 0.8. So let's say the next thing we're going to do is add a value to it. In this case, I'm going to do a multiple regression. So what I'm going to do is I'm doing a model, and I'm doing a this model. I'm going to do this model, and I'm going to say I'm going to predict Y by the year, and then I also included a gross domestic product just to say, well, what is the health of the basic economy? Maybe earnings is based on that. So I'm going to go ahead and run that, and I get a whole bunch of things here also. Again, I get a R-squared. It didn't improve very much. In fact, the adjusted R-squared went down. The adjusted R-squared goes down when you add more variables, so that's actually a worse model. And you can see the ANOVA, this is 0.04, which is not super significant. The thing that's kind of bad is that these values, so you see this is the equation of the model. Where's the equation of the model? Well, we can see it here. The intercept is minus this number, and the year is 230 times the year, and the GDP has the effect of 0.4. But you can see the probability that these values are 0 is pretty high. So this model is actually a worse fitting model using the GDP. Now what you'll want to do is continue to add variables or subtract variables until we get a good model. So I'm actually going to add another model, another variable that I'm going to call dummy. And the reason I'm doing that is because I look at these values and I see this particular year is really a bad year. And so I'm imagining maybe something funny went in that year, so I'm going to put a 1 in there. And I was just going to say, well, maybe that'll sort of correct, because that was such a bad year. Maybe it'll correct my earnings a bit. So I'm going to go again and try to do this, where I'm going to project earnings. And I'm not going to do GDP again. I'm just going to do year and then the dummy variable. See if I can run that. Oh, look, I got a much better R squared, 0.47. The adjusted R squared is 0.46. But also an interesting thing here, if we look at this, the year is significant, and so is this dummy variable. So that means that particular year had the effect of a minus 1827 for that particular year. And you can see it down here. You can see it in the plot. I don't know if you can see it. So anyway, this looks like a better model. So you're going to continue to do models until you get this up to like 0.8 or so. In this case, 0.74, that's pretty good. If this was one division, I might just go on to the next division and say, okay, I have an idea of what this model should be. So I hope that helps you see how we're going to be doing forecasting a little bit into the future.